Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Physics 5054, Cambridge O levels. We are working on the solar system, and in this video, we are going to talk about the solar system, its sun, and the planets around it. The focus of today's video will be on describe the solar system in terms of one star, planets, moons, and smaller solar system bodies. Describe the orbit of the Earth around the Sun as an ellipse. Analyze and interpret planetary data. Know what effect the gravitational field strength of a planet, what affects the gravitational field strength of a planet. Calculate the time it takes for light to travel large distances in the solar system. Explain why planets orbit the sun and know that gravitational attraction of the sun is what keeps an object in orbit and in orbit around the sun. Know the effect of the distance from the sun on gravitational field and orbital speed of the planets. In this topic, you will learn that all the bodies in the solar system move under the influence of the gravitational attraction of the large mass of the sun. The orbit of the Earth around the sun is nearly circular, but comets travel far away before returning close to the sun after a considerable period of time. Moons orbit planets bound by the gravitation of the planet. Light from the sun takes about 8 minutes to reach the Earth. Space programs have allowed much data to be collected about the planets and other objects in our solar system. You will learn how to use of some of this data and why planets nearer to the sun travel faster in their orbits. So, the solar system. The solar system consists of one star, the sun, and 8 planets moving around it in elliptical orbits, slightly flattened circles. It also includes minor planets and asteroids which orbit the sun, moons that orbit many of the planets, and smaller solar system bodies such as comets and natural satellites. The 4 inner planets, Mercury, Venus, Earth, and Mars, are all small, of similar size, solid and rocky, with a layered structure and have a high density. The 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, are much larger and colder and consist mainly of gases. Their density is low. These outer planets have many moons and other natural satellites in the form of rings of icy materials. Most of the dwarf planets, the best known of which is Pluto, orbit the sun at average distances greater than Neptune. These are trans-Neptunian objects, or we call them TNos, and together with their satellites, number over 2,000. They are generally of low density and are thought to be composed of a mixture of rock and ice. So if you look at here, so we have here Mercury, Venus, Earth, and Mars. These are the inner planets, and the outer planets are Jupiter, Saturn, Uranus, and Neptune. This is the asteroid belt, and these are the asteroids. So these are the inner planets and these are the outer planets. The solar system distances from the sun not to the scale in this figure. Okay. The asteroids are pieces of rock of various sizes, which mostly orbit the sun in the asteroid belt between Mars and Jupiter. So basically, they are okay. So basically, they are talking about this place. Okay. The asteroids are pieces of rock of various sizes which mostly orbit the sun in the asteroid belt between Mars and Jupiter. Their density is similar to that of the inner planets. If they enter the Earth's atmosphere, they burn up and fall to Earth as meteors or shooting stars. The largest asteroid Ceres is classed as a dwarf planet. Asteroids are presently classified as minor planets, which are defined as any object that orbits a star that does not have a large enough mass for gravitational attraction to have pulled it into a spherical shape. Larger asteroids such as Ceres are classified as dwarf planets if they have enough mass and a gravitational field strength high enough to have formed the spherical shape, but not enough to attract and clear the area around them of the smaller objects. Comets consist of dust embedded in ice made from water and methane and are sometimes called dirty snowballs. Their density is similar to the outer planets, and they orbit the sun in highly elliptical orbits and are much closer to it at some times than others, as shown in the figure 6.1.6. So I will show you the elliptical shape. They return to the inner solar system at regular intervals, but in many cases, these intervals are so long owing to the journey far beyond Pluto that they cannot be predicted. On approaching the sun, the dust and gas are blown backwards by radiation pressure from the sun, and the comet develops a bright head and long tail pointing away from the sun. One of the most famous is Halley Comet, which visits the inner solar system about every 76 years, the last occasion being 1986. The sun is a star and produces its own light. The planets and our moon are seen from Earth by reflected solar light. So this is elliptical, and I have done a video today on the elliptical shape. So this is the focus of the elliptical. This will be the focus of the elliptical. Here will be the center of the elliptical, and you can see the orbit of the comet is in the shape of the elliptical, and ellipse, the shape is ellipse. Okay, so the sun is at this focus of this ellipse. So this is the elliptical orbit of a comet. Elliptical orbits, you should watch that video, my video which I have done on the ellipse, and you will understand the word focus, the center. Okay, so in the same playlist you can find this video. The planets, dwarf planets and comets orbit the sun in an ellipse. The sun is at one focus of the ellipse. Okay, so this sentence you will understand if you watch that video. Okay, the sun is here. This is called the focus 1. This is the focus 2. Here will be the center of the ellipse. Not the sun is at one focus of the ellipse, not the center, as is shown in the figure 6.1.6. For a comet with a highly elliptical path, the focus is not close to the center of the ellipse. For approximately circular paths of planets, the focus can be taken as the center. So this is that elliptical path and elliptical orbit of a comet. Orbits of the planets are mostly circular, but the comets, their orbit is elliptical. So this is the diagram of the Halley comet. More than 99% of the total, mass of the solar system is concentrated in the sun itself. So it exerts a very high gravitational attraction that keeps objects such as the planets orbiting around it. Gravitational field strength of a planet. Newton proposed that all objects in the universe having mass attract each other with a force called gravity. The greater the mass of each object and the smaller their distance apart, the greater is the force. If you have the distance quadruples the force, means that if the distance between the two bodies become half, the force between them, the force of gravitational attraction, that becomes 4 times. For a planet, the gravitational field strength at its surface depends on its mass and is nearly uniform across its surface. The strength of the gravitational field decreases as the distance from the planet increases. The travel times. The planets and their moons are visible from Earth only because they reflect light from the sun. The outer regions of the solar system are over 5,000 million kilometers from the sun, and even light takes time to travel to such distant places. So here we have the worked example, and they say calculate the time t for the light from the sun to reach the Earth. From the equation, the average speed is equal to total distance by total time. Rearrange the equation to give time, so the total time will be equal to the total distance divided by the speed. If we take the distance of the Earth from the sun to be 1.5 expo 11 meter, and the speed of the light to be 3 expo 8 meter per second, then the time will be 1.5 expo 11 divided by 3 expo 8 equals to, and that will be 500 seconds, which is about 8 minutes. Okay, so here we have some questions for practice. Okay, so then we have the planets. Facts and figures about the sun, earth, moon, and planets are listed in the table 6.1.1 and 6.1.2. Times are given in Earth's hours, days, or years, as H stands for hours, D stands for days, and Y stands for years, as well as being of the general interest. This data indicate factors that affect conditions on the surface of the planets and some of the environmental problems that a visitor visit or attempted colonization would encounter. So, for example, this is the data for the sun, earth, and the moon. Here are the masses. The mass of the moon is 2 expo 30. The mass of the earth is 6 expo 24, and the moon's mass is 7.4 expo 22 kg. The radius of the sun is 7 expo 8 meter. Radius of the earth is 6.4 expo 6 meters. Radius of the moon is 1.7 expo 6 meter. The density kg per meter cube of the sun is 1410 kg per meter cube. Of the earth is 5520 kg per meter cube. And the moon's density is 3340 kg per meter cube. Surface gravity, the surface gravity of the sun, which is measured in Newton per kg, that is 274. On the earth, it is 9.8, and on the moon, it is approximately 1.7. The orbital period, the earth completes the one round of its orbit in 365 days around the sun, and the moon completes its orbit in 27 days, and it is around the Earth. So this is the data for the sun, Earth, and the moon. The data for the planets. Okay, the Mercury and its average distance from the sun, and that is in million kilometers. The Mercury is 57.9 million kilometer away from the sun. The Venus is 108.2 million kilometer away from the sun. Earth is 149.6 million kilometer away from the sun. The Mars is 227.9 million kilometer away. The Jupiter is 778.6 million kilometer away. The Saturn is 1433.5 million kilometer away. The Uranus is 2872.5 million kilometers away from the sun. The Neptune is 4495.1 million kilometers away from the sun. The orbit time around the sun, days or years. The Mercury complete one orbit around the sun in 88 Earth days. Venus do this in 225 days. The Earth complete the orbit in 365 days. Mars complete the orbit in 687 days. Jupiter complete its orbit in 11.9 years. Saturn complete its orbit in 29.5 years. Uranus completes its orbit in 84 years. Neptune completes its orbit in 165 years. The surface temperature of the Mercury in degree centigrade is 350 degrees centigrade. The Venus is 460 degrees centigrade. The Earth is 20 degrees centigrade. Mars is minus 23 degrees centigrade. Jupiter is minus 120 degrees centigrade. Saturn's surface temperature is minus 180 degrees centigrade. Uranus is minus 210 degrees centigrade. And the Neptune is minus 220 degrees centigrade. The density is in kg per meter cube. The Mercury is 5427 kg per meter cube. The Venus is 5243 kg per meter cube. The Earth is 5514 kg per meter cube. Mars is 3933 kg per meter cube. Jupiter is 1326 kg per meter cube. Saturn is 687 kg per meter cube. Uranus is 1271 kg per meter cube. Neptune is 1638 kg per meter cube. The diameter of the Mercury is 4.8 kilo, means 4.8 expo 3 kilometer. Venus, its diameter will be 12.1 expo 3 kilometer. The diameter of the Earth is 12.8 expo 3 kilometer. Mars is 6.8 expo 3 kilometer. The Jupiter is 143 expo 3 kilometer. Saturn is 120 expo 3 kilometer. Uranus diameter is 51 expo 3 kilometer. And the Neptune is 50 expo 3 kilometer. Mass, and it is in the kgs, and expo 24 kg. The mass of the Mercury is 0.0330 expo 24 kg. The mass of the Venus is 4.87 expo 24 kg, and the Earth's mass is 5.97 expo 24 kg. And the mass of the Mars is 0.642 expo 24 kg, and Jupiter's mass is 1898 expo 24 kg, and Saturn's mass is 568 expo 24 kg, and Uranus mass is 86.8 expo 24 kg, and the Neptune's mass is 102 expo 24 kg. The surface gravity, which is in the Newton, we call it the gravitational field strength, which is represented with the small g, is units are Newton per kg. On the Mercury, it is 3.7 Newton per kg. On Venus, it is 8.9 Newton per kg. On Earth, it is 9.8 Newton per kg. On Mars, it is 3.7 Newton per kg. On Jupiter, it is 23.1 Newton per kg. On Saturn, it's 9 Newton per kg. On Uranus, it is 8.7 Newton per kg. And on Neptune, it is 11 Newton per kg. The number of the moons around the Mercury, we have no moons. Around the Venus, we have no moons. Around Earth, we have 1 moon. The Mars has 2 moons. The Jupiter has 79 moons. And the Saturn has 82 moons. Uranus has 27 moons. And the Neptune has 14 moons. So, my dear students, this is the data for the Sun and Earth and the Moon. So I hope this video has been a long video. So we will cut this and then we will continue with this chapter. My advice to you is that keep watching my videos on the solar system, because after the completing this session of the reading of the textbook, we are using 2 textbooks. One textbook is different. This textbook right now, which you are watching, this is that IGCSE Cambridge O-Levels book, and this chapter is from there. And I hope that this will help you. And this data is very important. And so thank you very much, everyone. Keep watching the videos on the solar system from my channel and see a lot of documentaries on this, so you can master this concept. So thank you very much, everyone. And please like this video, share this video. Also subscribe on my channel. Thank you very much. Have a good day. God bless you all.